Okay, college algebra, this is the second part, or the second half of lesson 4.3's notes. We're going to start here with example 5. And with example 5, it says that we are given the fact that log base 10 of 7 is 0.8451. And then we're going to find each of these logs based on that logarithmic value. Now, for these questions, you might put a big star next to them. You need to show your work. And when I look at your homework, I will be looking at these in particular for the work that you showed, because you have to show me that you're using this piece of information to find your answer. So what we want to do is figure out how to write 49 with sevens, because that's the information we have. We know that 49 is 7 squared, or 7 times 7. So you can do the problem a couple different ways. If I do 7 squared for 49, then I will move the 2 out front. And then log base 10 of 7 is that value that I highlighted up here in yellow. So then I'm going to make a substitution. And then you're just going to double 0.8451. 1.6902. Now, if instead you said log base 10 was 7 times 7, then you're going to have log base 10 of 7 plus log base 10 of 7, and then you would have 0.8451 plus 0.8451, and you would still get the same answer. For this next one, I have to figure out how to break down 70 with 7. So what I'm going to do is 70 is 7 times 10. Notice I'm using factors to break these numbers down. Okay. All right, now I'm following the rule that if I have an argument of 2 factors, that I can add the 2 logarithms together. I know that log base 10 of 7 right here is 0.8451. Log base 10 of 10 is 1. I'm going to add those 2 together. And there's your answer. The next part of your lesson, we're going to be graphing logarithms. Now, the easiest way for me to get you to graph a logarithm is to switch it to an exponential. Now, this might be different than how you graph them in Algebra 2. If I switch it to an exponential, that's going to say 2 is my base to the y equals x. When I do my xy table for this, everything's backwards, because now my equation is solved for x and not for y. So I need to pick exponents out. I need to pick out y's first. I'm going to plug those y values in to get x's. So if I plug in 0, I get 1, 2, 4, 1/2, 1/4. And then I'm going to graph. So 1/4 negative 2, 1/2 negative 1, 1, 0, 2, 1, 4, 2. And there's my graph. It is the inverse of y equals 2 to the x. So the other way you could graph this is to graph this from lesson 4.1. And just switch your ordered pairs. So you can see for the inverse, they're backwards. So logarithms and your exponentials, they're inverses of each other. Let me undo that real quick. This graph right here is this one right here. Okay, if you're graphing y equals 2 to the x, it will be that reflection of this pink curve. In fact, let me go ahead and put this in a different color so we don't get confused. All right. Now, the domain and range of this pink curve, the domain, it starts at 0 and goes to the right. The range, all reals. All right, I'm going to do the same thing on this one. And then we'll talk about something else that we could do differently if we didn't want to change it to an exponential. So there's a couple ways to do this problem as well. All right, I'm going to switch it to an exponential. Those parentheses stay around the argument until I switch it over. So my base is 2 to the y. At this time, I can take off my parentheses. I'm going to solve it for x. I'm going to build my table. I'm going to choose y values again. When I plug in 0, I have 2 to the 0 minus 2. That's 1 minus 2, so that's negative 1. 2 to the first minus 2, that's going to be 0. 2 to the second minus 2, that'll be 2. 2 to the negative first minus 2. That's 1/2 minus 2, so negative 1 1/2. And then 2 to the negative second minus 2 is 1/4 minus 2. So that's negative 1 3/4. Okay, now we're going to graph. Okay, so somewhere there. All right, now what I have, this right here produces an vertical asymptote at x equals negative 2. If I compare these two graphs, you can see that if I take this pink curve from up above and shift it to the left 2, I'm going to have my new black curve here. So this is y equals log base 2 of x moved left 2. So you can also do transformations if you want. I chose not to do that initially. I chose to just go and solve for x instead of just sliding my graph from before over. All right, we're going to also solve this one for x just to get you used to that. Again, if you want to do it with transformations, this will take our pink graph and move it up 2. So there's the transformation. I, however, like to do my XY tables, so now this one, notice there's no parentheses. So when I have parentheses, that moves the original left or right. And when I have no parentheses, I'm moving the graph up or down. So for this problem, I'm moving it up 2, and there's no parentheses. So what you need to do first is go ahead and get that 2 to the other side. And that gives you the log by itself, which is what I need if I'm going to switch it to an exponential. So my base is 2, my new exponent is y minus 2, and that equals x. Now when I set up my xy table, I'm still picking y's first, but because I'm subtracting 2 away first, I'm going to start the middle of my table with 2. And then go backwards and forward, and then plug in my value. So 2 minus 2 is 0, and 2 to the 0 is 1. 3 minus 2 is 1, so 2 to the first, and then 2 to the second. Putting in a 1, that becomes 2 to the negative 1/2, so that's, I'm sorry, 2 to the negative first, and so that's 1/2. And likewise, this is going to be 1/4. I think I have a mistake in here somewhere. Let's see. How about 4, 4? There we go. Just looking at that. A little bit perplexed. Okay, so here's our graph. So you can see that everything's been shifted up 2. What's the domain? 0 to infinity. What's the range? All reals. And let's go back and catch that on the previous example. Our domain, -2 to infinity, and our range, all reals. Okay. That is the end of lesson 4.3. Let me know if you guys have any questions.